Hello friends, in this problem we have to solve for a, and you have been given an equation, and this equation is, in the numerator you have been given a plus 2 times a plus 3 times a plus 4 times a plus 5, and similar term you have in the denominator. Only difference is you have a negative sign, and this is equals to 1. So how will you solve this problem? Now if you look closely, then you will see that this is 3 and this is 4. If you sum these two, so this becomes 7. Similarly, here also you have 5 and 2, and if you sum, then this becomes 7. This suggests that we can keep these two terms together. So let us do that. So we will have a plus 2, and I will club this with a plus 5, and similarly a plus 3 times a plus 4, and in the denominator I will do the same thing, and you will have a minus 3 times a minus 4, and this is equals to 1. Now let us multiply these terms. So we will multiply these two terms, similarly these two terms and these two terms. So you can have, if you multiply, you will have a square plus 7a plus 10. So this is for this term. Similarly, here you can have a square plus 7a plus 12. And this divided by, here you will have a square minus 7a minus 10. No, minus, this is plus 10. Because minus minus becomes plus. So this is a square minus 7a and plus 12. And this is equals to 1. Now let us make a substitution, that is, this term is equals to x and this term is equals to y. So this is x and this is y. So this means a square plus 7a plus 10 is equals to x, and a square minus 7a plus 10 is equals to y. So with this substitution I can write this is x, and this will be x plus 2 because you have 12, and similarly this is y, and this will be y plus 2. So this is y, and then you will have y plus 2, and this is equals to 1. Now let us cross multiply. So you will have x into x plus 2 is equals to y into y plus 2. So this is x square plus 2x, and this is equals to y square plus 2y. Let us take y square this side and 2x that side. So we will have 2y minus 2x. Now x square minus y square, this is what? This is a square minus b square, that is a plus b into a minus b. So this will be x minus y into x plus y. And if you take 2 common, so this will be y minus x. Now let us take this y minus x this side. So we will have x minus y, x plus y minus 2 times y minus x is equals to 0. Or I can write x minus y into x plus y, and let us observe the minus sign. So we will have 2 times x minus y is equals to 0. So now you can see you have x minus y here, and this term is also here. So you can take common x minus y. If you take common, you are left with x plus y plus 2. This is equals to 0. So now the two situations, either this term will be 0 or this term will be 0. So let us consider two cases. The first case, when x minus y is equals to 0, this means x is equals to y. And what is x and what is y? If you remember, this is x and this is y. So we can equate these two things. So we will have a square plus 7a plus 10 is equals to a square minus 7a plus 10. And from here you can say this will be 14a is equals to 0. So this is 14, a is equals to 0. This means a equals to 0. So a equals to 0 is one solution of this equation. Now let us consider case 2. So in this case you have x plus y plus 2 is equals to 0. This means you will have a square minus 7a plus 10 plus first plus because x is plus and y is minus x square minus 7a plus 10 plus 2 is equals to 0. So what you will have, this 7a cancels out. You will have 2a square and then 10 plus 10 20 plus 2 22 is equals to 0. This means a square is equals to minus 11. This means a is equals to plus minus a square root of minus 11. So this root is imaginary. So I can write this is a is equals to plus minus under root 11i, and this root is imaginary, and that's why this root is not accepted because a belongs to real number set. So in this case we have only one solution, and that solution is a is equals to 0. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video, and I will see you in the next video. Thank you.